Hi. This project is to reduce the cost of a high-end vending machine manufactured by Chapco and sold by Fastcorp in Chester, Connecticut. Dasong Mi and Cal Petrozello are the mechanical engineering students partnering with Fastcorp and Chapco on this project. The Divvy, the name of the vending machine, which is an acronym for Dream It Vend It, is a high-end robotic vending machine that uses a robotic arm with a suction cup to pick up items stored in a chest freezer. Chapco partners with Fastcorp for product manufacturing. Chapco has some of the largest sheet metal capability in all of Connecticut, and we are able to take advantage of this for our engineering design.
Our sponsors challenge us by finding any possible way to increase the profit margin of Fastcorp's vending machine. After analyzing possible solutions, we decided it was best to redesign the subassembly that opens the freezer inside the vending machine. The strategy is to simplify the manufacturing and supply chain to add value and reduce cost. Our solution reduced the assembly time by 85% by eliminating the majority of fastening operations to assemble the subassembly. Our design eliminates 13 out of the 16 original fastening operations, all of the outsourced machine parts, and 1 out of 5 original in-house fabricated parts. The cost of the assembly to lift the freezer door is reduced by 40%. The price of the parts increased by about $20, mostly due to the price of new actuator used. However, the assembly time is reduced from 80 minutes to about 10 minutes. This saves about $85 on the overall design. This results in expected yearly saving of $15,000 to $25,000. The assembly features an electric linear actuator to provide the force and motion for lifting and closing the door. Having a pre-assembled actuator reduces assembly time. There is an adapter bracket that can be swapped for different types of freezer or item storage options. The actuator's end effector only latches onto the freezer door while it is fully open. This allows the operator or service technician to open the freezer door freely.
The linear actuator uses a 24-volt DC motor. The manufacturer sells different gear configurations for different speeds and strengths. We selected the best gearing option available using a math model we developed in MATLAB. The actuator is fastened to the bracket using a single clevis pin. This single-piece design, with a non-threaded fastener, reduces the assembly time and the number of tools needed to assemble the device.
The electronic controls are designed by the team and were used for prototyping. Using a limit switch and a motor driver, we can control the acceleration and the deceleration of the actuator for smooth operation. The programming logic is given to the sponsor, and it will be implemented into the vending machine electronic control design.
A structural analysis was conducted on the bracket that holds the actuator. The bracket is a galvanized, low-carbon steel and has a conservative yield strength of 30 ksi and a fatigue limit of 20 ksi. The actuator can provide a maximum force of 35 pounds. However, the force was not measured to exceed 20 pounds, but 35 pounds is used for a built-in factor of safety. Maximum stress in the part is 10.5 ksi and the bracket only deformed 0.013 of an inch. Because the stress is lower than the fatigue limit, the bracket is expected to last for an infinite number of cycles. We repeatedly cycled the opening and closing of the vending machine using the new design. Originally, the latch failed at 5,000 cycles. The team saw a design flaw that was overlooked and redesigned the part so it will last for a lifetime of the machine. There were no other failures observed. The final deliverable to the sponsor is the new subassembly design to open the freezer that reduces cost by 40%. Assembly instructions are provided for manufacturing, and programming logic is provided for the sponsor to implement into their control board design. This subassembly will first be implemented into the Divvy's larger cousin, the Divvy XL, and then swapped into the original Divvy once it receives a control board upgrade in the upcoming years.